Hello everyone, myself Pawan, and this is my second lecture of the ML series. And in this lecture we focus on what are the essential steps needed for the machine learning for data pre-processing. Because before, when we design any model and to supply any data to the machine learning model, the data pre-processing is the first useful step, because the accuracy of the model and the performance of the model is totally depend upon our data set. If we are provide the accurate data to the machine learning model, they will give the right answer to us. So in this video, we try to understand what are the essential steps are useful for the data pre-processing in the machine learning, right? As we mentioned in first video also, these are the machine learning life cycle. Before design any model, first we need the problem identify. After then, we need the data collection part. What is the useful data needed for the specified problem? Then we have the EDA, then we have the feature engineering, then we have the model training, then we have the model selection. At the last, we have the accuracy of the model, right? First, we try to understand what is the data. The data generally present in the different form to us. Either we have the source of data is the primary source, and sometimes we have the secondary source. And the primary source, we try to generate the data by their own way. Sometimes the data we are taking from different types of source. With some secondary source, we have some online source. For example, we have some online repository present of the machine learning. And the data is present either in the label form or the unlabeled form. We are called label data is called sometimes we are called the structured data, and we have the unstructured data. And sometimes we are called the label data is the supervised machine learning. Unlabeled data we are called the unsupervised machine learning. So data is either labeled or unlabeled, structured or unstructured, supervised or semi-supervised. Sometimes data is in the form of the semi-supervised also. We are called the semi-structured data. Generally data in the JSON format and the XML file found in the JSON format, right? Now, what is the data? Data is the raw information. And the information, we are divide the data in three types. Either data present in the numerical form, as mentioned in this. Data in the numerical data we have present. All the information of the data present in the feature in form of the number. For example, we have the age of a person. Suppose we have a data set, we have first we mentioned about the age of the person, and we have what is the salary there. We have two feature. One is the input feature is the age, and output is the income. We want to predict the model with as the age of the person increase, what their income will be. So data, both the input data in the form of the output data in form of the numeric value. Sometimes we have the different types of data is the categorical data. Means we represent the data in some label form. For example, we have the input feature, we have the male female. So we have the two feature to classify in two part, male female. Sometimes we have the temperature, high, medium, low. So this data can be present in both the input feature and the output feature also. Suppose we have the output feature, we classify either fail and pass. Means the value of the data in the data set, either the input feature and the output feature can be in the two types, in the category form. Not in two types, in category form we have the male, female, yes, no, temperature, high, medium, low. So in both cases, in the input feature and the output feature, right? The third type of data is the ordinal data set. Suppose we have not the category, we have some order of the data. We have the first, second, third. The size of cloth, small, medium, large, temperature, high, medium, low. So we have generally three types of data present in the data set, either in the numeric form, and we have the categorical form. Third is in ordinal form, right? We are talking about the supervised machine learning, mostly in the data set. Then we have the data collection part. As first step of this ML model is to identify the problem. Then we have what is the appropriate data needed for that. This second is most important step for this. And as we mentioned, we have the different resource of this. Sometimes we have the primary resource, we have the secondary resource for that. Let's suppose we are using the secondary resource for that. We use the online repository. There are some beautiful repository are present. They provide the very beautiful data to us. Like for example, Kaggle is one of the most important repository of the machine learning. We have the UCI machine learning also repository. You can take the appropriate data, the data is very beautifully present on this both online repository. And how can now we, after taking data, how can we implement the model? So we have two software tool for that. We have the Jupyter Notebook. It's a very beautiful help to be Python, making the Python program, right? And either we sometime we use the Google Colab for this. You can also design the model on this. So we have the two, mostly the two software for that. And we have the first one Jupyter Notebook, and the second is this Colab network, right? Then now the data types. The data either in the CSV format, and the data present from both repository either in form the CSV format, right? Sometimes data in the format of the JSON format. So CSV format is that mostly the text file format, the data in the form of the label form, right? Either in the form of the number form and the ordinal form, but in the label form, right? Sometimes data in the format of the JSON format, right? Present on the library. Sometimes with the help of the API, we try to import the data. This is also one of the best ways. Sometimes data is not present, and some of the website, they put the data on their website and they provide the API for that. With the help of the API, we try to abstract the data from their website, right? This is also one way to get the data from this API from this. Then we have the web scraping, very beautiful. With the help of this library present in the we have the use of the CSV format. I again repeat, JSON format. When we have take the data from the API. Last one is the web scraping. There are the four approaches to take the data from either from the primary source or the secondary source, right? Then after, the third most important step is the EDA of that. For the EDA is before to implement a model, first we have to analyze the data. With the help of this EDA, we analyze the data. We have the two approach to analyze the data. Either we analyze the data in the univariate analysis of the single variable. Suppose we have the one feature, we have the feature of the only age. So we try to analyze the only age feature, what the minimum age of the person, what the maximum age are present in the specified age features column, and what the mean of the age features, what is the median of this. So we are using the univariate analysis. Sometimes we analyze the two variable. Let's suppose we have the 10th and 12th marks. We want to analyze the 10th or 12th number. We have got the bivariate analysis. So EDA is a process that help data scientists to understand the structure and the pattern of the data set. With the help of this EDA, we try to understand what is the structure and pattern of the data set. In specify one features, and we have the two features. So we are mostly to use the univariate analysis and the bivariate analysis for that. And we have the number of the library present in the Python. We have one beautiful library is the matplotlib. With the help of this matplotlib, we try to design some beautiful relationship between the features value. And we have also the one beautiful library is the Seaborn library. So with the help of this matplotlib and the Seaborn library, we try to draw the number of the chart paper and graph for that, and to try to identify the analysis of the features either in the univariate and the bivariate, right? Then we have the feature engineering. This is one of the most important steps. It's called the data pre-processing step. The feature engineering is the process of the transforming the raw data into a feature that are suitable for the machine learning model. Means we have to prepare the data for the machine learning model to implement, right? So one of the beautiful is the feature transformation. Means we have to transfer the features in a such way they are ready to design a model. First is the handling of the missing value, right? Suppose we have the data set, we have the number of missing value are present. Then before to design a model, we have to remove this missing value. Then we have the encoding process, then we have the outlier, then we have the feature scaling. They are the four most important step in the feature transformation. Then we have the feature construction, and then we have the feature selection process and feature extraction process. There are the four process in the feature engineering. In this video, we try to focus only the first process is the feature transformation. Handling of the missing value, encoding, and the feature scaling. We are not also mentioned the outlier here. Only 3 points we are discussed. Handling missing value, encoding, and the feature scaling. In the next video, try to work on the feature selection process and the feature extraction, right? Missing value. Let's suppose there is no specified rule for this. Suppose we have the data set size is very small. Let's suppose we have the only 400 value in the data set. Out of 400, the 50 value are the missing value. in which the missing value play vary because the nearby the 20% less than 15% value are the missing value. So we have to fill this missing value, right? Sometimes we have the large data set. Suppose we have the 50,000 number of row entry, only 5 value are missing. So we, before to replace this missing value, we can also remove from the data set, right? So there is no predefined rule for to remove the missing value. If the size of data set is very small, we have to fill the missing value. If size is very, very large and very few value are missing, we have to simply remove this missing value, right? Now, how can remove, sorry, we are not remove, we are remove the number of the row only. Before to fill in the missing value, we delete the number of row, right? Now, question is that if the size is very small, how can fill this missing value, right? Now, we have the two types of data present. One is the data present in the form of the numeric value, right? Other we have data present in the categorical form or either in the ordinal form, right? So, how can we replace this? If data present in the numeric form, as mentioned before, if data present in the, we have the numeric data present or some value are missing, the specified feature. So, what we do, how can we fill this value? If data value feature is the numeric value, we have to fill the value with the help of the mean number, right? We try to calculate the mean value of this, right? And we are replaced with the mean and median value. For example, we have the age, they mention the age of the people and some value are missing from the specified feature. What we do? We have to simply calculate the mean value of the features and fill the all missing value with the help of the mean value, right? Or either median value. The maximum people use the mean value for that, right? If the data in the form of the category, suppose we have the male, female in input feature or either in output feature both, some value are missing, then what we use? So we try to fill the missing value with the value they are the mostly frequently used. For example, male, female, the male are used many times in the data set. If we check the male female ratio in a specified column, we found that the male feature is frequently used, number of time used, maximum number of time. So we have to try to fill the missing value with the specified value with the most frequently used, right? So we have the two approach. For the numeric value, we use the mean number, and for the categorical data, we replace with the most frequent value of that, right? Then we replace, third step, we remove the duplicate value. Suppose in data set we have the number of value are duplicate, we have to remove this because they unnecessarily they affect on the accuracy of the model, right? Then we have to use the analysis univariate EDA of that, right? We use for, I mentioned this, right? Then we have the feature encoding. The second most important step of the data pre-processing is the feature encoding. Means we have to be, what we use, let's suppose we have the encoding process, we have the male, female in a one features. But when we design the ML model work on the numeric data. So we have to replace this feature value with the help of this number value, right? So there's some most important step is the right was the nominal data. Let's suppose we have the feature, we have the some value of the state name, Haryana, Delhi, UP, MP. So there is no relationship between all of them. They are not in the order value. They are the nominal data set. So we have to replace this value with the help of the one hot encoding. We have to apply there. Let's suppose we have the value. They are in the order form. Let we have the mention the input feature. We have some order value. We have the male, female. We have the first, second, third. So we are use the ordinal encoding for that, right? Other one, last one is the category encoding. Suppose we have the output feature. Try to listen. In case of the input feature, let's suppose we have the input feature, the value are in the category form, in the ordinal form. We apply the ordinal encoding. If the output feature, the same we have the yes, no. We have to classify either placement or yes, no. They are also in two category, but we are use the label encoding. Means for the input feature, we have to apply the ordinal encoding. For the output feature, we have to apply the label encoding. If data in the nominal data set, we apply the one hot encoding. So three types of encoding we are use. One hot encoding, then we have the ordinal encoding, and we have the last one is the label encoding. As mentioned in this PPT also, let's suppose we have the data set, we have the name of the student, we have the other feature, male, female, 12th number, division, B.Tech, and the placement. This is our output feature. This is the output feature, and the all five are the input feature. So now what we have to do? Now we have to first change this value in a number form. Suppose we have remove first this, there is no use of this, we only focus on this 4 point. Let's suppose we in the first one, male, female, there are two division. They are the input feature, either male or female. They are in the two division, ordinal encoding. we apply the ordinal and they are in the category form, right? They are in the first one, this one. They are in the this one. So we apply the ordinal encoding for this, right? Suppose we have we simply use the category here, so we use the label encoding. Output feature, we apply the label encoding, yes, no. They are the numeric value, 12th value, and this one, we are use the numerical value here. We apply the ordinal encoding. What do you understand? If the input feature in the order form, we apply the ordinal encoding. If the output feature in the yes, no form, we apply the label encoding, right? Then we have the third step is the scaling of the data. What we do, we try to first remove the missing value by 2 value. If the number integer form, replace by the mean value. If they are in the category form, replace with the frequent item used. Then use the 3 types of encoding. If the input feature value in the order form, apply the ordinal encoding. Output feature, we apply the label encoding. If the input feature are not in the order form, we apply the one-hot encoding, right? Then we have the other step with the feature scaling. Sometimes what we show, let's suppose in the example, we have the 2 input feature. One is the age, other is the salary, and this is the output feature. So with the help of this input feature, we try to is a classified data. We have to identify either he or she purchased the house or not. So when we design a model, what we have seen, we have the 2 input model. Out of this 2 value, if we check the value of this 2 value, they are the 25 and this value. The difference in both of them is very high. The difference of both values is very high. If we design the model, there is a problem. So feature scaling try to be standardize the feature input feature. Right? What happened? We have to change this value in such a way, there is the difference is very high, both of them. 25 and this value, difference is very high. So what we do? We try to change in normalize the data set. In value between the 0 and 1, sometimes the -1 and 1. So we have the number of approach are used for that, because if we design the model in such a way, the problem comes in the accuracy of the model, right? So what we do? We have the number of the method approach for this. Out of this approach, we use the any one of them to standardize the independent feature, right? First, we have the min max method, then we have the standard, we have the normalize. There are some approach for this. You can use the any one of them. If we use the min max, they scale value between 0 and 1. What happen? They try to change the all value in between 0 and 1, and same the salary features in the 0 and 1, right? They are the input feature. Then we have the feature selection approach. This one, as mentioned, this one. The feature selection approach. This is very beautiful. And before to apply the feature selection, what we do? The first part is over. Data pre-processing. We prepare the data to remove the or missing value. Then the encoding process. Then feature scaling. Now we have the feature selection process. Right? Before to selection of the features, what we do? We have to identify some point. First, we have to remove the overfitting problem. Right? When we design the any model, we have to focus on that. We have to select the feature in such a way. If suppose we have the feature value, we are take the excess of the feature to design the model. The problem overfitting. If we are take the minimum number of features, the problem of the underfitting, right? So sometimes we have to be selection of the feature. We have to keep either we are take the excess of data, problem overfitting. If take the minimum data, problem underfitting. And then we have the process time slow, increase the model performance. These are 4 parameters we are needed to design the feature selection. And thank you very much. In the next video, we try to focus on how the number of approach used for the feature selection. Thank you very much.